So welcome. This short video is going to be looking at hydrolysis of polyesters, looking at how we can cleave that ester linkage using either hot aqueous acid or hot aqueous alkali. We're going to start off with acid hydrolysis. So that is using H plus and H2O to cleave this ester bond here. Now we're going to basically go back to making the original products, or the original reactants should I say, that would have been used to form this polyester in the first place. So we're going to be making a dicarboxylic acid and a diol. We need to bear in mind that the number of moles of water needed are going to be related to the number of repeating units that you have present. So if I have one of each of these molecules produced, then I will have needed 2 moles of water to create this process. So this is the acid hydrolysis of an ester linkage, and we're going to use hot aqueous acid to carry this out. Okay, so let's have a look at what happens if we do alkaline hydrolysis instead. So here we're in the presence of a strong alkali like sodium hydroxide in addition to our water, and where we might have produced a dicarboxylic acid, now because that acid is in the presence of a strong alkali, we're going to have a salt produced instead. So that means that we're going to be making the sodium salt of our dicarboxylate, and we're still going to produce a diol. So because this isn't an acid or a base, we still get the diol produced, but here we would have formed our dicarboxylic acid, but because that H plus that would have been on here reacts with the OH minus that's present from the sodium hydroxide, our products end up as being this diethanoate base, not ethanoate, dicarboxylate base, that's more accurate. So again, we need to bear in mind that we're going to need as many moles of sodium hydroxide and water as we have repeating units. So you don't have to show a mechanism, we just need to be able to predict how each of these is going to be produced. So on the next slide, I'm going to give you some chains of polymer, and I would like you to predict for me under both acid and alkaline hydrolysis what new materials are going to be produced. So let's give you those examples now. So here are your 2 polymers. Can you please show me what the 2 products will be from acid hydrolysis and what the 2 products will be from alkaline hydrolysis of each of these, please. Press pause here to do your work, and I'll show you the mechanisms that I've come up with. So let's start off on here by identifying where we've got some of those ester linkages. We've got here more than one full repeating unit, so it's going to be important that I identify that as well. So I've got an ester linkage here and here and here, and that means that one full repeating unit is going to essentially be coming through this bracket here. Okay, and if I look at what happens with my acid hydrolysis, then I'm going to be adding hydrogen to form my diol and adding OH groups to form my dicarboxylic acid. And if I show you off to the right with my alkaline hydrolysis, here I'm going to use sodium hydroxide and water, so I'm still going to get my alcohol produced, my diol, but now I'm going to be making the sodium salt of that carboxylate instead of, let's just shift that over so you can hopefully see what I've written. I've got the sodium salt there at the bottom. Okay, so hopefully you can see where each of those products has come from, and I'll show you for the second example that I gave you. Okay, so this was that second polymer that I gave you. Just like before, let's go through and find the ester linkages that are going to be cleaved, and then let's identify one repeating unit so that we can see how this will go on to behave. So I've got an ester linkage here. I'm just looking at any bonds between oxygens and carbonyls. I've got another one here and another here, and so that suggests that my repeating unit is going to go through those outer two ester linkages. So as before, let's have a think about first of all with my acid hydrolysis. I've got H+ and water present, and I'm going to add an OH onto each of those carbonyls to make my dicarboxylic acid, and then my hydrogen to form that diol. So in this case it's some kind of diphenyl. Off to the right then, let's look at what's made when I use my hot aqueous alkali. So we have sodium hydroxide, again in the presence of water, and just as before we're going to form a sodium salt of that carboxylate. So we're not making a carboxylic acid, because essentially that carboxylic acid would have formed, but then the H+ or the hydrogen that's present in the carboxylic acid group is going to go off to neutralise the OH that's present, so we get the sodium salt formed, but we'll get exactly the same diol formed as previously. So I hope you've had a look at some of those web links that I put up. I'll try and find you an exam question to put on the notebook page as well, but I hope that you can see where that's come from. The next video I'll show you is hydrolysis of polyamides. Well done, good work.